Welcome all. I'm Jan de Vries. I'm a cloud solution architect working at 4.net, a small consulting company based in the Netherlands. And over there I do, well, a lot of Azure solutions, a lot of awesome stuff. And whenever I find something awesome to talk about, I, well, keep a blog, and for all of this stuff, I've got the MVP award, the Azure space. So I'm kind of happy with this. Lately, for the past couple of years, the past 3 years, I guess, I've been much focused on Azure Functions. I do a lot of stuff with it, both in, well, proof of concept applications and production, and I'm quite fond of it. And if you want to know something about it, just ask me later on, and maybe I'll be able to answer something, maybe not. Something you might not know about me is I've been bartending quite some time in the past. I guess I've been a bartender for like 6 or 7 years or so, and I was quite happy with this job because it, well, paid the bills. I was a student and I was loaded in cash and did awesome stuff with, well, serving beers and doing cool stuff, working at awesome hours like 4 till 4, because that's what you do. But one thing I noticed is, which has some similarities with the IT space, is working with clients is hard. Clients are very picky at what they want. Uh, some people like to know, like it when they come in to the bar and you serve a beer directly, because you know, hey, that's Case, he wants a beer. Or hey, that's Heather, she wants a red wine. Or hey, that's John Doe and he wants plain water. Some people don't like this. So you have to know how to approach people, how to work with them, stuff like this. I'm not a people person, I'm a beta person, so I didn't like this part of the job. And it's also the part of the job I don't like a lot in the IT department. Because when working with clients, for example, the HTTP client, you have to remember. I hear a couple of people laughing. You have to remember the HTTP client doesn't like to be disposed, doesn't like to be closed, doesn't like to be invoked or created multiple times in your application. That's something you have to remember, otherwise your stuff will break in production. Also, we have, of course, the SQL connection, which is also some kind of a client. We have the DocumentDB client. A lot of clients, maybe even for your third-party apps, they probably also have clients. You have to know how to work with them. Most of them can be disposed and can be instanced, well, dozens of times. Some of them don't, and some of them need some obscure ways of disposing them, of getting rid of them. So that's hard, and that's not stuff I like, because I'm a simple guy. I like simple solutions. I don't like to remember all of this difficult stuff. So that's why I like Azure Functions. But before I continue, I have to do some mise en place, some preparing of the session, or at least preparing of the future of this session. So what I did, you can see, right? Duplicate. Well, I'll just zoom in. So what I did is I have a couple of queues, and this is just to show you how hard it is to work with clients. I have a couple of queues created, wrong implementation and 2 correct implementations. Doesn't matter much what they're called, it's about what they do. So I was a bit late at preparing the first part of this session. So I started the wrong implementation worker a bit late. So it had to process like 10,000 messages in the service bus queue. And the way this worker is working is via a wrong way. It invokes a new HTTP client each time a message is being handled. And I'll show you later on what happens for the people who don't know what happens. So 10,000 Messages will be processed. So let's just zoom out. And I have 3 workers over here. Well, only 2 of me, and this DAS I got for free by clicking on the wrong buttons in Azure. So this my web job worker is running at the moment and processing through the wrong implementation queue. And what it does is creating a new HTTP client each time the message is being processed. So I'll just stop it right now. And we have to note the time. It's like, well, 5 past. It's like, well, I remember this, 35 minutes. So disabling, stopped. So I have a second web job. It's the correct web job, and what this web job does is exactly the same compared to the web job who does has the wrong implementation of the working with the HTTP client. But this one doesn't create new instances of this client. It just uses one and keeps reusing this. So this one is stopped. Let's just start this one. Wait a second. Refresh. Starting. That's cool. Running. Oh, just to be sure. Where's the Service Bus Explorer? If you don't know of the existence of the Service Bus Explorer, you should check this out. You can install it via Chocolatey, and if you're doing anything with service bus queues, you want this, or topics. If you're doing anything with the service bus, you want this this thing installed. So every week I come across developers who don't know about this tool, and it's amazing. It's the best there is available, sadly. So as I mentioned, we know this new correct web job has started, and it's now processing messages from the correct implementation net framework queue. And the wrong implementation has stopped processing. Yeah, it's 2570 still. So cool. Yeah. So it's going down. So that's the preparation I needed to take. Let's just start. Oh, start again. Cool. Click on this thingy. So that's the preparation. So most of you are familiar with the serverless space. Maybe not. Maybe so. Done something with it. Well, then I'll just go real fast through this slide, because serverless doesn't mean there aren't any servers anymore. This is Jeff Holland, if you can see him in this picture, and he's not standing in the serverless data center at the moment. This is just an empty data center. The serverless data center, the Azure Functions data center, lives inside. Sorry? This is the German? Yeah, they also don't need servers because they're German. So, but sorry, that wasn't very inclusive for me. Sorry. No, but the Azure Functions really live inside the Azure App Service servers, because it's a layer on top of Azure App Services. Because servers are still there and serverless, the Azure Functions are a bit like PaaS. It's actually very much similar to PaaS. Adrian Cockcroft, one important guy at AWS, at least at the time he tweeted this. He's like the Scott Guthrie of AWS. So he said, if your PaaS solution can spin up really fast, spin down really fast and get destroyed, and do some compute in between, you can call your serverless solution or your PaaS solution serverless. And while this only counts for the compute part, of course, and there are a dozen of nuances to this quote, it is a nice elevator pitch to get the conversation started with your customer. Because serverless isn't much different compared to PaaS. It's just more awesome. So there's another guy called Paul Johnston who lives in the UK, And he's also, or he was, an important guy. He's like the cloud developer advocate of AWS, not anymore. But now he does. Well, I don't know what he does. But he's working. He's one of the pioneers in the serverless space, and he has worked with this, or to his saying, about 8 or 9 years in this space. I don't know how this can be true because the serverless space doesn't exist this long, or at least not to my knowledge. But at least he's awesome. He has a lot of opinions on stuff, and a lot of has done a lot of good production deployments. And during his time, he has seen some best practices which you should adopt when going serverless. So he's blogged about them. It's like 8. This is the URL. You can look it up later on. And what it all comes down to, all of his best practices, it comes down to you should be thinking like you're in a cloud environment, because you are, and this means you aren't on a legacy and on-premises environment anymore. Because when working on premises, you're probably limited to what your operations team and yourself can handle. Because being a consultant, I get to go to a lot of customers, and I've seen some pretty obscure solutions, which work, but they're pretty obscure. I've seen file systems, folders being used as a queue. I've seen SQL tables being used as a queue. I've seen, well, you don't want to know what I've seen, but it's all because of they're working in an on-premises environment, and convincing your operations team, or maybe even your manager, to install RabbitMQ on one of your virtual machines, or Kafka, or whatever, well, they're probably going to say, yeah, about that, let's just use something else, because we don't know how to work with it, how to manage this. It costs a lot of money, probably. And most of the time, the operations people are already stuck with a lot of work, and they don't have the availability to learn something new. So I understand this, but when in the cloud, you can just press a couple of buttons, and a new Kafka cluster is being created. You can just create a new service bus. You can create dozens and dozens of storage accounts and use them, because it's simple, and the management of it is rather easy. There are a lot of management tools for it, and the costs are marginal, because compared to doing all of the stuff on premises. And that's what all of Paul Johnson, his best practices, are come down to. Use the cloud capabilities in your serverless environments, because serverless is a cloud-born thing, and you should be using it in a cloud-first solution. So there, as I mentioned, there are 8 principles he has on his blog post, or at least last time I've read it, maybe updated it. And there are 3 I want to discuss or talk about today, which relate to custom bindings for Azure Functions, and abstracting away those awful clients. The first one, maybe one of the most important, is one function, be it a Lambda, a Google Cloud function, or an Azure function, should only do one thing, and it should do it well. And I agree fully with this statement, because if your function is doing only one thing, it's probably rather small, so easy to test, easy to deploy, and easy to update. And it has a small footprint. You could even go this far as stating an Azure function or a function should not contain if statements. Which, if you think about it, if you implement an if statement in your code, you have 2 execution paths, which you have to test, which you have to run, which you have to manage later on. I think this is going a bit too far, like not using if statements or switches or whatever, because then you'll end up with dozens and dozens of functions which only have 1, 2, maybe 3 lines of code. And of course, if you've read the clean code book, I guess Uncle Bob will be pretty happy with this. But having gazillions of different functions deployed in your function app has some management overhead. So just keep it sane. Keep it sane. The one function should do one thing. Use zero libraries if possible. So I'm a big fan of AutoMapper, AutoVec. I almost always use Entity Framework because that's, well, what everybody is using. But I prefer not using those libraries, those frameworks when working with Azure Functions. You want to know why? Because their footprint, their memory footprint is, well, quite large compared to the functionality you want to use. Entity Framework, I guess that's like 6 megabytes. I haven't checked. But AutoMapper and AutoVec I have checked, and their assemblies are like 250 kilobytes in size. So if you use both of them for dependency injection and mapping some DTOs around, you'll end up with, well, half a megabyte you need just for loading, half a megabyte of memory you need just for loading all of your dependencies. And you haven't even done something in your own code. So and the bigger your Azure function is, the bigger your function app is, the slower your cold start will be. Because what's a cold start? If you've heard of Azure Functions or whatever serverless compute offering, you probably hear something about, yeah, cold starts are a pain and we can't use the serverless thing because of the cold starts. Well, I don't agree with this statement, but you can reduce drastically the cold start times when your memory footprint, when your function app footprint is rather small. Think about it. If your application is 1 kilobyte in size, you only have to move 1 kilobyte of your function app to a data center, to an app service, to a virtual machine, to whatever, which is a lot faster compared to having a function app which is 6 megabytes, because that takes a lot of time. I've been a SharePoint developer in the past, and I know the pain of doing IIS resets all day long, because most of the time I spent as a SharePoint developer was waiting for IIS to catch up for my SharePoint site to boot up. So that's the cold start. And this cold start you also have, well, with the serverless offerings. So don't use libraries, because doing dependency injection by yourself is okay. It's rather easy to do once you've done it a couple of times. Mapping a property to a different property on a different object, and that's one line of code. Maybe 5 if you want to map 5 different properties. So you don't need AutoMapper for this. Of course, these libraries offer a lot more stuff and a lot of awesome stuff. That's why I use them in every other scenario, every other app service. But you don't, most of the time, don't need them with Azure Functions. And the last principle he describes is know how it will scale. And this is a bit of a strange one, because when going serverless, you're being told you don't have to know how it will scale, you don't have to know about infrastructure, you don't have to know about VMs and stuff like this. But it's actually quite useful if you do. Because know how it will scale, you can also use this to your advantage. Because if you, I've met a couple of people who thought when they're invoking an Azure function via HTTP or whatever, each invocation would spin up a new Azure function. Well, this would be an ideal scenario, but this isn't the case due to performance reasons. So whenever an Azure function is being hit, this is being kept alive for the lifetime of about 20 minutes. Another Azure MVP, Mikhail Shilkov, maybe you know him, has some interesting blog posts about this. And he has done some measurements on when an Azure function or a Lambda or a Google Cloud function will die off and do a new cold start. I recommend you read up on his blog post, because it's amazing stuff what he's done. But knowing this, you can also use this. And that's what I'm using for my custom bindings in Azure Functions and abstracting away my clients. Because if I know my Azure Function instance will be kept alive, I can keep some state in my Azure function. And I know, this is a bit of a blasphemy, keeping state in an Azure function, because we're all told don't keep state, they should be stateless. Yeah, that's true. But you can use this to your advantage, because why, if you're using AutoFac, would you spin up, or why would you create a new container every time an invocation happens of your Azure function? It doesn't make a lot of sense, because it takes milliseconds, and you're paying for those milliseconds. If you want to cache something, well, you can do this if you want, and it will be kept alive for the lifetime of your Azure function. But that's something you have to know. You can use. I don't say you should be using it, but you can use it. But use it with caution. But that's useful to know. And there are a lot of other quirks where it's useful to know how the underlying platform works at the moment. So I mentioned it a couple of times, custom bindings, because Azure Functions, well, kind of lives on bindings and triggers. Whenever something happens in the cloud, in Azure, there's probably some trigger for it, which an Azure function can use, like a message is being posted on a service bus, a storage queue, or maybe a blob file is being placed in some container. These are all triggers where an Azure function can spin up on. The same goes for bindings. If your Azure function is invoked, you can use some binding to, well, store or read data from a Cosmos DB, a SQL Server, file storage, whatever. Those are bindings. But most of these out-of-the-box triggers and bindings only work for Azure resources, which makes sense because Azure functions. It's in the name. So a lot of people start complaining, yeah, I want to integrate with Slack, I want to integrate with Teams, I want to integrate with SAP for whatever reason. So what the team has come up with, I think it's 1.5 years ago, is having the capability of creating your own custom bindings. So if you have a reason you want to integrate with Oracle databases, for example, well, just roll your own custom binding and be done with it. The team isn't going to create those bindings. You can. You can also create custom triggers, but I wouldn't do this at the moment. They're a bit flaky. They work sometimes, and that's not something you want in a production environment, or at least not when I'm on call. So don't use custom triggers at the moment. There's still a lot of in development. The team isn't very happy on people creating custom bindings either, because it's also a bit in development, and they say it's sometimes a bit flaky. I haven't experienced this yet myself. Custom bindings are rock solid in my experience. That's the caution part of it. So I use my custom bindings to abstract away those hard to manage clients, like HTTP clients, SQL connections, DocumentDB clients, stuff like this. I'm even busy with creating a Microsoft Teams binding, because why not? That's awesome. Integrating all of the stuff. So to show you how easy it is to create your own custom bindings, I've created a small demo for this. The first hello world, you can look this up in the documentation also if you want, but if you follow the documentation, you'll quickly see this doesn't work. So that's why I have this session and a blog post about it. So what I've done, yeah, it's readable, or at least for me it's readable. For you all also, yeah, I don't hear someone screaming, so that's good. So what I've done is I followed the tutorial on GitHub, or I guess on docs.microsoft. There's probably a mirror on it. And what it does is it reads some content of a file located on my own disk. So this is a binding which doesn't exist, because most of the time you don't want to read files from a local disk in a production environment. So what I've created is my simple model. It only has the full file path and the content of a file, or at least it should have later on, and my simple binding attribute, which is an attribute, of course, and I have to specify location where to get the file from. So I have this notation over here. Using this means I want to get the file path from my environment variables, from my configuration, from somewhere configured, and the name is something which is passed along in the in the URL in this case. So that's all convention for Azure Functions, and I can even use them over here, but I don't. So what this Azure Function does is, do I have ReSharper over here? No. Then it's this. So I have this attribute and this binding, and this is the most important part. If to create a binding, you have to implement the iExtension config provider, and what you get from this interface is an initialize method. And in this initialize method, you have to create binding rules in order to create your custom binding. So I'm specifying over here, I have a special attribute for my simple binding. I want to create a rule for it, and I want to bind it to some model, my simple model, and I've created some method for it to create this model from the attribute which is passed along. So this is rather easy. I could also add a new bind to input over here. Oh, that's difficult, adding white space to a file. But I could also string over here, and that would enable me to also map to a string when using this binding. Of course, I have to create a new method for this in order to create a string output for this input, bind to input. So that's rather straightforward. So what I do over here is I read out the argument, the attribute. I check if the location exists, and if so, I read the text and put the text inside the content of this file. So let's see if this still works. It worked yesterday, so I have great hopes. It's all on localhost, so it should just work. So I'm starting it up. The console, the function runtime should spin up. There it is. Waiting. So as you can see, there's this custom binding function. Maybe it wasn't very clear, but I have this custom binding function which is using my simple binding. So it's over here, localhost custom binding with a name. Of course, I also have Postman set up, and let's just zoom in. Localhost custom binding test send, and testing my message. So this works. You might not believe me, but I actually have a file called test, where this is the context. Azure Thursday save. Just to prove for the people who don't believe me on my blue eyes. Azure Thursday, awesome, right? So that's the Hello World implementation of custom bindings. But as I mentioned, this doesn't work, or at least this isn't all what you need to do, and this is all which is stated in the documentation, or at least last time I've read it. Because what you also need to do, which I found after doing Googling for like days, is you have to add a startup class, an iWebJob startup, and configure in the startup, in the WebJobs builder, you have this simple binding. You have this extension added to your system. And I was like, what? It does mind blown. I don't want to do this stuff because WebJobs is stuff I've used in 2018, in 2017. This is legacy stuff. So I was no, but it actually made a lot of sense because Azure Functions, as I mentioned, are built on top of app services, and WebJobs live inside web services. So you could state Azure Functions are just WebJobs on steroids. Their Azure Functions are awesome WebJobs because they scale, and WebJobs, well, are WebJobs. So you need to add this add extension, my simple binding, and then it will work. Or at least that's what I thought. Because what you also need to do is expose the assembly. So add this line, or at least depending on what your project is called, of course, but add this to your project, and then you can reference this assembly, my first custom binding library, to your Azure Function app, and it will work. So that's all you have to know, and you can find this on my GitHub, of course, but that's all you need to do in order to start using custom bindings. You might say, yeah, I don't want to use a local file reader in my Azure Functions because that doesn't make sense. And it doesn't, but it's the easiest thing to get started with custom bindings because you can't mess up, or at least most of us can't mess up reading a file from local disk. So this is easy to do when using the local emulator. As I already mentioned, it is useful to abstract away those hard to use those hard to use clients like the HTTP client. So I like picking on the HTTP client. So maybe stop. Oh. Okay. So what I've done over here is what have I done over here? Oh, this one is using a private static HTTP client, which works, but it's too much plumbing in my opinion. So what this does is this function will read something from the service bus, so the correct implementation net standard. It's the other queue you saw in the Service Bus Explorer, and will get all of the 10,000 messages from it and do something with it. It will retrieve some data from an Echo API I've created. And this works. This is the advised route, or at least somewhat the advised route, by keeping a private static method of your HTTP client so it can be reused in an Azure function. Useful stuff, but who likes this? I don't, because this is just the HTTP client, and now I also want SQL and DocumentDB and sub client and whatever. So should I add dozens and dozens of private static fields? No, of course not. I can use custom bindings. So I'll just comment it out because this is yucky. What is awesome is this. Now I can just use some abstraction, and we all know abstractions are cool because that's what makes our life awesome. So what I've done over here is, well, pretty much the same, or at least this is empty because it's abstracted away inside the HTTP binding. So I had a lot of code over here, like 2 lines to do something, and now I only have an attribute, which is 1 line, which is much better, of course, and I am doing some get. So how have I implemented this? Well, it's pretty much the same implementation compared to having this private static read only. I now have this HTTP attribute, of course. I've just turned off ReSharper a couple of weeks ago because I want to get the full experience of Visual Studio, but have to get used to the key bindings. So what I've done over here is have an HTTP attribute inside this HTTP binding class, and I have the same stuff like the my simple binding attribute extension, yada yada yada. I have the same stuff over here. I have the attribute, I have the binding for the binding rule, the HTTP attribute, and I'm doing some get magic over here. And this HTTP client is kept in memory in an internal static HTTP client. This could also be private. That's my first commit, private, and it will still work, or at least this get binding will still work because it can access this HTTP client. But getting stuff from an endpoint, well, is good. It's a read endpoint of HTTP, but I also want to post stuff. having an output binding internal. So I'll just change this. And for this, for creating an output binding, you have to do about the same. You have to create a rule and a bind to a collector in this case. So the people who are familiar with Azure Functions and using the iasync collector, which you probably use for Cosmos DB and other collection stuff, this is the stuff you need to do for this. So if you have a bind to collector with, well, some attribute, you can create an output binding. And this output binding makes the stuff even better, because now you can add a lot of commands to inside your code and add it, and whenever flushing, so whenever the flush happens, it will be post or put to your resource. All the while you're using the same HTTP client, which is kept in memory, of course, in your HTTP binding. This way, your customer or your application developer who adds value to the company doesn't have to keep track of all of these nasty private read-only HTTP clients, but just can use an out-of-the-box or a company custom binding and just get stuff done. So what I have over here is the command client. So I have a HTTP command binding, having the iasync collector of the HTTP command, and adding a command to the collection, and it will get, I guess it will get posted. Yeah, it will get posted to the specified endpoint, the API echo command endpoint. And that's all there is to it. So this flush, for the people wondering, this flush happens over here. So after this function ends, the flush will happen. So you can imagine you probably don't want to do stuff which takes about 5 minutes, because I haven't looked up what the limits are, but I can imagine that the function runtime wants this flush to happen within a reasonable amount of time. So keep an eye out for long-running operations happening in the flush. But that's all there is to it, and much more elegant. So of course these examples are a bit silly, because well, keeping track of the HTTP client is easy, but when your solution grows and grows and grows, you probably don't keep track of all of your HTTP clients in this case, because that's hard, and you have to keep track of all of your, well, functions. So using something like a standard binding is much more useful and will help you in the future, or at least that this is the stuff I'm using in production systems now, and it helps us a lot. So that's the HTTP client. I also, because I was busy and got the hang of it, I also wanted to try this for SQL Server. Because for SQL Server, as I mentioned, I don't fancy using Entity Framework just for normal CRUD operations, because Entity Framework is awesome if you want to do a lot of stuff, and it has a lot of capabilities. But most of us are just doing some select star from table where ID is ID. And yeah, adding Entity Framework for that type of queries is a bit of an overkill. So I started with creating a binding for it. So a SQL Server attribute, of course, you need a connection string, a query or a command. I'm still working on this one, because the command is the hard part, because you want to validate the update or the insert, and it's a bit more difficult compared to the get model. But what I'm doing over here is I have a SQL Server model which does stuff, and also an INumeral. These are the get commands. So I have a select star from table, and then I'll get results. And this is all of the stuff I need to do when using ADO.NET. So finding this code, you can't find this code in Stack Overflow, because no one is doing ADO.NET nowadays. So I found some sites which I visited like in 2005 and 2003 with markup from those days. those ancient sites, and yeah, that's how I have to open up a connection and do stuff and using well magic. So, but now I have this abstracted away in some kind of custom binding, and I don't have to worry myself with all of the stuff opening and closing connections, and I just get a fairly a nice collection of SQL Server models over here. And this is where I think custom bindings really shine, because the HTTP client example just abstracts away one line of code. And you could say, yeah, it's a lot of overhead to abstract one line of code. But abstracting away this stuff makes sense to me, because what I can do now in my Azure functions is, well, do what I want is go to this SQL Server function, having the SQL Server binding, do a select from a table, get a collection, and be done with it. And because I'm using the dynamic, I can just use the ID over here. Of course, it doesn't have autocomplete, but 3 lines above, I know which columns I've queried. So do I actually need autocomplete? Nah, I can just read in this small function what I have in this property bag, this dynamic. So this is where it actually makes a lot of sense, and there are a lot of other clients, of course, where it will actually make sense abstracting away this block of code and making it one simple binding. So I see a lot of people adding stuff for Slack for this, even creating their own Cosmos DB bindings, because the out-of-the-box Cosmos DB binding you have is rather simple. It's good enough for, well, these use cases like a select and a select top 100. But if you want to do a bit more fancy stuff, you probably want to roll your own. So that's what actually makes a lot of sense. And of course, all of these custom bindings need the startup class with the binding added to it. So that's what you need to know, and that now you see how awesome it is. So I hope this emptying the queue is almost done. Yeah, I've talked through all of the queue, so that's good. So it's at 0. And now I'll show you why it makes sense to abstract away this HTTP client for the people who haven't experienced this yet. So it's still running. I'll just stop it. And diagnose and solve problems. The reason I created web jobs for this, like these old things, is because you can't see this tab in an Azure Function app service. I don't know why. Well, I can imagine why, but I don't know for sure. You can't see how many sockets are open on your app service. And you can when using web jobs, because they just live on one server or two. But at least Azure can report on this. So when using, so that's why I've used web jobs, in order to get this tab to see how many socket connections were open at a specific point in time. So as you can see, before I started my session, there were like 2,000 socket connections open, because my wrong web job was creating a lot of HTTP clients. I can show you the code. My web job, it has a function, and what it does is creating a new HTTP client, do some get to an Echo API. And this is if you have 10,000 messages on a queue and each of them needs to get processed, it will open up, well, depending on how fast your web job is, it will open up 10,000 socket connections on your app service, and that's not allowed, because an app service is an isolated piece of code. It's a sandboxed. So when you're having an app service of the size S1, you have like 2,000 open socket connections. You have going to S2, you have 4,000, and going to an S3, you have 8,000, and that's the limit. You can get more as 8,000 open socket connections on app services at this time. So that's why That's why my web job got throttled at, well, about 2000 connections. It's a bit small, but you'll just have to believe me. Well, I can zoom in. So about 2000 connections, and that's about the limit. I guess it's 1800 something something, and it adds up depending on the level you are. So when going to 35, I said. So it's, well, I guess it's over here also. It's about when I started my correct web job, so the web job which reuses my HTTP client, I only have 30 open socket connections, and that's exactly the amount of threads your web job is working on. So each thread has its own HTTP client, and you only have 30 open socket connections, which is better compared to 2000. So apparently I've 2 instances. That's great. Cool. Oh no, total and outbound. Okay, cool. So that's a lot better, in my opinion. You also see some fancy error message, and you can add alerting and monitoring to this. But yeah, if you don't watch out, this will work. Creating a new HTTP client in your virtual machine or on premises will work, and you probably won't run out of sockets because you have, well, a practical infinite amount of sockets you can open. And if you outrun them, just install SQL or just install Windows Server, the newest version, and you get a lot more. So if you specify some details in the configuration, but don't do this. Just be a good citizen and use the stuff like it is supposed to, like reusing the HTTP client in this correct web job. Yeah. So when to use this? Well, as I already mentioned, you want to use this with expensive stuff. You could even like keeping alive of all of your clients, like SQL connections. Well, you don't want to keep them alive, but stuff you want to keep alive or abstract away complex logic. So that's why when you want to use those custom bindings. Also, if you want to use caching, or maybe even you want to do some dependency injection magic with a custom binding. I don't know why. You could use it for a service locator maybe. I'm just thinking out loud. But expensive stuff. When stuff you want to keep alive and complex logic you want to abstract away. That's when you want to use custom bindings. They're awesome, and they let you focus, or they let your application developers focus on adding business value. Because no manager, no product owner, no CEO has ever paid me to write ADO.NET logic or to keep track of how to work with HTTP clients or DocumentDB clients. They all paid me to deliver solutions for their business problems. So when using custom bindings, and maybe later on in the future also custom triggers, you can focus on adding, well, you only have to write it once, and afterwards you can focus on adding business value to your customer, to your stakeholders. And you don't even have to write it once, because all of these functions I've shown you are available on GitHub, and you can just download them, and I get a +1 on the downloads on NuGet, so that's good for my ego. So you don't even have to well, write it, you can just use it. So that's about it for this evening. If you're interested in the code or want to file an issue, just check out my GitHub, and there's the repository on the SQL Server binding, the HTTP binding, event grid binding, and, well, some other stuff. And if you find issues, I found a couple of myself, just post them, create pull requests, or contact me on Twitter, via email, or on my blog. Thank you all for listening, and a great evening. The question is, isn't there an idle timeout on the connections?
So, like you say, you keep it alive.
Yeah.
If I do like for 20 minutes nothing with it,
Yeah.
my connection closes anyway.
Yeah. So the question is, isn't there an idle timeout on the connections? I think you mean the for specific. Yeah, for the socket. Yeah, there is. There is a timeout for the HTTP client, or there's one specified in RFC. We've done some extensive research on it because we were throttled. And the RFC says when closing an HTTP client, the underlying socket has 30 seconds to respond, and afterwards will get closed, which is nice, of course, and works most of the time, unless you have a lot of load, and then a lot of sockets will be opened, and you will reach the limits. So yeah, it will time out eventually, but you can still run into problems. So after those, when Azure function dies, after 20 minutes of being idle, this socket will also close and will be released on the app service, the underlying app service, the underlying VM. And you won't notice this, but it will take about 30 seconds. And we noticed this RFC isn't adhered very well. We also seen some sockets being kept alive a bit longer as 30 seconds. I don't know the specifics about it anymore because, well, I don't know the specifics anymore, but they should at least, yeah, close. But you can run into troubles with it. I hope that answers your question. Maybe. Yeah. So the question is, uh, can can you use my extensions written in C# in your own language of choice, like Node.js, PowerShell, PHP, Java, whichever language is supported? I don't think so. I haven't tried it, but it's IL code underneath. It's a NuGet package, it's a DLL, and I don't think Node.js can work very well with DLLs. Neither can Java, neither can PowerShell. I guess it will work, but I'm a C# guy. Sometimes I try F#, uh, but I haven't tried it, so I can't know for sure. But when think about it, I don't think it will work. You have to write your own for different languages. Any other questions? One in the back. Sorry, I can't I can't hear it. So so the question is, what do I think of the dependency injection capabilities of the Azure Function runtime? A good summarized, yeah. I would, if you can, I would always use the built-in stuff compared to other stuff. So I love using Autofag, and I use it almost all the time. But using the built-in stuff most of the time is a lot faster. I haven't done some performance testing on it, but I would use the built-in stuff. And indeed, when using .NET Core, for example, the HTTP client, you don't have to create it your own. You have in Core, you have this factory around it, so you can use this one, and it will do all of the magic for you. So yeah, please use the built-in dependency injection stuff if you can. If you need some capabilities of a third-party framework, use a third party. Cool. Any other questions? No? Thank you.